Yeah, and here are the algorithms for computing bi-cluster or computing pattern-based clusters or different pattern-based clusters. So here's the algorithms for constant bi-clusters, which is one of the classical problems stated by Hartigan already in the 1970s, 1970s. So he came up with a quality measure for a bi-cluster, which is actually the variance of the submatrix, which can be computed here. So you just compare the actual value with the mean value of the cluster, and you try to minimize this variance, obviously, of the submatrix, and then report those submatrices that have the smallest variance first of all. And Hartigan proposed recursive splits of the data matrix into two partitions. So each split tries to reduce the overall sum of squares for all. So this sum of squares, so the variance for all bi-clusters. So you try to find that split such that bisecting split such that this variance is small for all bi-clusters. And of course, you may overfit in terms of partitioning into singularity bi-clusters. So each row and each object as pair is a perfect bi-cluster probably, which optimizes the sum of the squares, but you can try to avoid that. So Hartigan proposed to compare the reduction of this trivial thing or overfitting thing with the reduction expected by chance, and if that is smaller, then you take it. If it's not smaller, then you probably leave it. So that's the original algorithm for constant bi-clusters. Then for constant values and constant in rows and columns, the simplest approach is a normalization to transform the bi-clusters into constant bi-clusters. You can transform both problems in the constant bi-cluster problem and then follow just the first approach. And then there are some other approaches which are basically application driven with special assumptions. For example, in the bioinformatics community, having special assumptions from the application that people try to use in order to find those clusters a little more efficient. So constant values in columns are typically general access parallel subspace clusters, so you could apply them also. Constant values in rows are special cases of general correlation clustering algorithms, so you can also use those algorithms for that. And both cases are special cases of approaches to bi-clusters with coherent values. So you could also use those algorithms, of course. For the pattern-based clustering algorithms, which is the bi-clusters for coherent values, the classical approach is by Chen and Church in 2000. They also introduced the term bi-clustering for the analysis of gene expression data, and they defined the quality of a bi-cluster by the mean squared residue, which is this one here. This is just the variance of the cluster as we had before, and they look for submatrices such that this mean squared residue is smaller than a given input parameter, delta. And of course, if delta is 0, so if the mean square residue is 0, then the bi-cluster is perfect, obviously. And actually, the model for a perfect bi-cluster can be used in order to formulate the whole thing as an optimization problem. So the model for a perfect bi-cluster predicts a value for this for any value in any row and any column, by a row constant and by a column constant and an overall cluster constant, which is this one here. So the value of a perfect bi-cluster can be predicted by those three values, obviously. Well, this is just the thing we had before. This is just a definition, and we can now use some tricky mathematics such that we see that each row and column exhibit absolutely this constant biases. So they have the same bias actually, which is the mean of the cluster. Yeah, so mu is the mean of the cluster, and in that case both the row variation and the column variation have the same bias, this constant value here. Yeah, and for a non-perfect bicluster, now the prediction of the model deviates, obviously, because it's non-perfect, and the prediction of this value here deviates from the true value by some residue, by some error term. This is the error term here. This is what we had before, and we can use this residue to optimize for. So this is actually the optimization criterion for the mean square residue we had before. Yeah, as you have a look at here, this one exactly looks like this one here. So yeah, you can formulate this as an optimization problem, and ask some solving algorithms to solve that for you. Yes, there are some related algorithms, just to name them. There's an algorithm called p-cluster, specializing on delta bicluster property. Then there is flock, which uses a randomized procedure. Maple for improved pruning. co-class, which uses a k-means-like approach. So you see, the story behind that is the search space for those perfect or non-perfect biclusters here is quite huge, and people have to employ heuristics in order to efficiently search for that, and that's why there are a lot of different algorithms, basically differing in different heuristics to apply. Yeah. Again, related algorithms are biclustering models that do not fit exactly to into the spatial intuition behind our spatial intuition of subspace clusters, projected clusters, correlation clusters. But okay, the models have been designed in the view of the data matrix, so they make most sense in the view of the data matrix. Yeah, and well, as a discussion, the strong point for those models is that they are very general and do not rely on the locality assumption. It's just some kind of data matrix pattern. Yeah. But the models, however, differ substantially. So be quite careful in what you select, because it might not be exactly the pattern you look for. Yeah. So model selection in that case, in the right sense, is again here not a trivial task. Yeah. So don't underestimate that. Yeah, that was pattern-based clustering actually. And yeah, as I told you before, we will have the week off next week. Yeah, and we will, or I will talk to you about correlation clustering in 2 weeks. I hope you use the day off and then the week off to catch up. So it's not to be, you should not consider it to be holidays, but as a catch up or a reading week. So. And if I'm talking about ketchup, I don't mean Paradeiserpaste. So in that sense, stay tuned. Try to behave good, and yeah, see you in 2 weeks. Talk to you in 2 weeks.